Hello, good morning, friends. And today we are going to see the fiber optics and laser instrumentation. It is very important for the say army purpose or military defense research, satellites, communications, and all the safety and say research related. So electronic appliance or electrical appliances, which is applying the fiber optics and communication industries, so electronics industry. So those are those for those industries where we are using the fiber optics and laser instrumentation applications. And now we are going to see this is a very high-fi engineering, so which is related to high technology engineering. So we are in this kind of study. Actually, we are going to, I mean, in fiber optics and laser instrumentation department, we are going to study about fiber fundamentals of fiber optics, theory and classification of fiber optics, properties, characteristics. So merits and demerits of this classification of fiber optics and optical fiber production, technology of performed fabrications, fiber drawing, material consideration, fiber material considerations, and so when applying the fiber optics or related material, what is the loss and bandwidth the limiting mechanism, how to limit the bandwidth or maximize the bandwidth, and mechanical and related to fiber optics and laser instrumentation, we have mechanical and thermal characteristics of laser and fiber. So how to measure the characteristics, how to monitor, and then how to control it. And so we have the study of light resources for the fiber optics and photodetectors and source of coupling, then fiber connections and the splices, and then splicing techniques and everything. And then fiber optic instrumentation in the field of fiber optic communication system setup, and different types of modulators, oscillators, detectors, application in instrumentation, right? Actually, in oscillators or detectors or modulators, we have a lot of application in instrumentation to measure the say crystal oscillators and everything. How to measure the frequency of oscillation? Based on that, you can determine the frequency of the wave and sound, right? Then we have optical sensors, and then pressure, temperature, or displacement or acceleration, torque, strain, fluid level, and viscosity, electrical and magnetic field sensors based on the polarization effect. So in my previous video, I have told actually the process parameter in the sense actually flow, velocity, level, temperature, pressure, and everything. Other than that, we have displacement, then acceleration, and torque, strain, and viscosity, elasticity, and all these comprises of process measurements, right? So which are and also we are going to studying about electrical and magnetic field sensors based on the polarization effects, right? And then we have fundamentals of lasers. So laser rate equations, some technical calculation is required. How much of fiber can accommodate the laser and the say you can say the fiber beats and everything. How to construct it, how to propagate the laser wave. So these laser rate equations will help you to understand. And three-level systems are there. We have four-level systems, and then properties of laser beams, laser modes, and ronator configurations, and Q switching, mobile locking, and cavity dumping using the single frequency operations. And then actually we have I mean actually normally we will study these types of lasers. So ruby lasers and lot of lasers, monochromatic lasers, dichromatic lasers, lot of different types of lasers can be used, and gas lasers, solid lasers, liquid lasers, semiconductor lasers, PN are related, right? Actually, some laser diodes, and then we will study the industrial application of laser. See how the laser is used for the measurements of distance. So how the length is measured, atmospheric effects and pollutants. How the displacement of the material is measured using the lasers. How the acceleration is measured using the laser, the rotation of wheel, right, based on how much frequency, how much the laser wavelength or beam it cuts per a minute actually, so we can determine the speed. and then torque can be measured using the laser operated devices in instrumentation, and strain, stress, fluid level. So laser can be transmitted to the bottom of the ocean, can like a sonar kind of thing, and how much time it will take for the travel to the deep sea, sea or ocean bottom, ocean floor, and again it reflects from the bottom of the ocean, and again receive in the receiver. How much time for the transmission and reception, right? From that actually you can see the sea level or any fluid level. So anything, say any hazardous liquid or something, say how much level it is there. Actually, say we can decide. Say if a person is fallen down on a particular, I can say public usage of drainage, underground pipes or everything, or wells or something. So we need to rescue them. For that, actually, we need to find the exact level of depth or level of bottom, actually, where actually we need to prepare one tube or something to rescue the people, and also to create oxygen, right? Atmospheric oxygen inside it. We need to pressurize the air into that, so that a particular person can take breathe the oxygen, right, to make him live, right? That is very important. So industrial applications of lasers, in the sense we have laser for measurements of distances, length, atmospheric effects and pollutants, and then material processings, and then laser heating, melting, scribing, trimmering, welding, material removal and vaporization. And also this vaporization and all these things, right, can be used for fusing, say even use it for the eye cataract operations and everything. So where instrumentation is required, how much how much frequency, or how intensity the laser to be focused to create a cut in that and remove the I can say uh, the deposited material in the cataract kind of thing, right? So called actually we can see called cataract operations. So this will fuse, this laser vapor will fuse that particular thing, and then actually liquefy that, and then actually it will be again, it will stitch, right? Instead of doing the equipment surgery, we can open heart surgery. We are using laser surgery, and so we have the calculation of power requirement for the laser, for the material processing and everything, and then holography and the biomedical applications, uh, helography, and the basic principles or methods of helographic interferometry and related applications. Helography for non-destructive testing. In case of industrial equipments, we need to test for the non-destructive testing. So those, for that actually we are using lasers, and medical applications of lasers and tissue interaction, and laser instrument for microsurgery, removal of tumors in the vocal cords, brain surgery, plastic surgery, dermatology, skin related, gynecology, and oncology, and then actually we have eye related operations, hair related operations, anything actually, even actually laser operation can be used for very minute parts actually in a human body, and even for animals they were using lasers for operations, right? So when you're asking about the reference books, we have Kaiser Optical Fiber Communication System, McGraw-Hill Limited, 1983, and then DC OSHA and W. Russell Collin, Introduction to Laser and Applications, Addison Wesley, published in 1978. So H.M. Smith, Principle of Holography, John Wiley and Sons, 1975, and then A.K. Ghatak and K. Tyagarajan, Optical Fiber Electronics and Foundation books published in 1991. So these are the applications of lasers, actually, I can say. So if a person is interested in laser instrumentation or fiber optic instrumentation, so they can have a strong knowledge in fiber optics and laser. But again, actually in India we have better scope. In only in US and Europe actually we have a big scope for the laser and optical fiber communication instrumentation. So I think you need to be prepared for the worst history, friends. So it's a good field, but the entry is very, I mean, is not that much good. Only in DRDO or ISRO or a kind of scientific labs actually we are using, and scope is very less in India. But whereas in foreign or I can say US or I can say Europe, we have Australia, we have a lot of opportunities for these students. Thanks, friends. I hope the details I have given is very useful on the laser and fiber optic instrumentation. Thanks, friends.